Now that we've learned how to determine the number of significant figures a measurement has, we need to talk about how to do calculations with measurements. There are two basic rules to know: addition and subtraction, and multiplication and division. Let's start with addition. Let's think about driving home from the store. You look down at your odometer and notice that it reads 5.2 miles. Recall that that last digit is actually an estimate. Your car doesn't actually have the precision to tell you more information. The real value could be anywhere between 5.150 miles all the way to 5.249 miles. Now, that means we're plus or minus roughly 250 feet. So when we drove all the way home, we know the distance to be 5.2 plus or minus 250 feet. So when we got home, we parked too close to the garage, so we had to back up a little bit. Say we backed up 1 foot. That would make our trip 5.2 miles minus 1 foot. We can't compare miles to feet directly, so I have to convert it. 1 foot is approximately 0.000189 miles. So we traveled 5.2 miles minus 0.000189. As you can see, this is so small, it doesn't really affect the outcome. Because if we're plus or minus 250 feet, adding 1 more foot is not going to make a big difference. So in the end, we say we traveled 5.2 miles. The rule for addition and subtraction of sig figs is you keep the least number of decimal places. Comparing our two numbers we just subtracted, 5.2 miles and 0.000189 miles. The large number, we have the ones place and the 1 over 10 place. Whereas the small number, we don't even have anything in the 1 over 10, the 1 over 100, the 1 over 1,000. We have to go to 1 over 10,000th place. So all the uncertainty in this big number swallows up the little one. When in doubt, remember that the big number can eat a small number because there's so much uncertainty in a large number. Let's do some examples. So example number 1, we have 3,828.6 grams. We subtract from that 810 grams. Here we have a number that has the hundreds and the tens, but no significant figure in the ones place. Whereas on the left, even though it's a bigger number, we have it all the way down to the 1 over 10, the ones. So the uncertainty is dominated by the 810 grams. Our calculator will tell us 3,018.6 grams. But this is incorrect. We need to round it according to the least certain measurement. In this case, it's the 810 grams, so we need to round to the tenths place, meaning our final answer is going to be 3,020 grams. For our second example, we have 6.02 liters, and we add to that 1.0115 liters, which our calculator would tell us is 7.0315 liters, which is not to the correct number of sig figs. So looking at the first number, we have a ones place, a 1 over 10 place, and a 1 over 100. The second number has a 1 place, a 1 over 10 place, 1 over 100, 1 over 1,000, and 1 over 10,000. So the 6.02 dominates our calculation, meaning we have to round our final answer to the 1 over 100th place, giving us a final answer of 7.03 liters. Now let's talk about the multiplication rule. Imagine that you are tasked with measuring the area of a field. You and your lab partner decide to split up tasks. You painstakingly measure your side of the rectangle. You take hours of effort and get 30.1256 meters. So you measured it down to the 10th of a millimeter. Your lab partner, on the other hand, is not quite as motivated. He looks at the field and says, it's about 100 meters. Recall that area is equal to length times width. So you take your number, as accurate as it is, and you have to multiply it by the inaccurate number of your partner. A calculator would tell you 3,012.56 meters squared. However, our partner only gave us a measurement to 1 sig fig, so we have a large range of uncertainty. There's a good chance your partner could be off by as much as 50 meters. So we have to round our answer to a single significant figure. This means all the hard work we did to get all these digits in our measurement were lost by one bad measurement. A bad measurement can derail an entire experiment, causing you to lose information. The rule for multiplication and division is you keep the least amount of significant figures. Let's do a couple more examples. Example 3. We have 3.0 meters and we want to multiply 1.52 meters. If you just plug it into your calculator, you get 4.56 meters squared. Now this first number only has 2 sig figs, while the second number has 3. So the least number is 2, we have to round this number to 2 sig figs. Since we're dropping a 6, we have to round up to 4.6 meters squared. For example 4, let's say we start off with a measurement of 31.9988 grams. And we want to divide that by 2.00 liters. Our calculator will tell us that's 15.9994 grams per liter. When we look at the calculation, the bottom number has 3 sig figs. The top number has 1, 2, 3, 4, 5, 6 significant figures. This means we must round our final answer to 1, 2, 3 sig figs. Since the last number dropped as a 9, we have to round up, giving us 16.0 grams per liter. If you're thinking that the multiplication rule is easier to do than the addition one, you're in luck, because most of the problems we will encounter are multiplication or division. I do want to remind you, though, any counted number, or a defined number like a dozen, will not affect the number of sig figs in your answer.